Good afternoon. My name is Bob Wainwright, and I am here today with my longtime colleague and friend, Dr. Gideon Ariel,
Hi, Bob.
biomechanist extraordinaire and inventor of the Ariel Performance Analysis System and the Ariel Computerized Exercise System. We're here today to show our friends, colleagues, customers, present, past, and future of an update that we are working on for our APAS system, which we call APAS AI. In order to normally get a video digitized and present for data, we would have to have three methods of doing it. One would be to hand digitize it with the eye and the mouse. Second would be to digitize it with markers, which will be more automatic, but difficult to do outdoors. And now we have within our capability the APAS AI. So in order to demonstrate how we do this, we'll start with clicking on the APAS AI screen, and we're going to choose to do a discus player for you this afternoon. We have an opportunity to select the video that we want to digitize automatically. And in this case, I am choosing this discus trimmed video. Open. And I decide that is the one I want, so I'll come down to start processing. And we see that the AI program is automatically digitizing the figure frame by frame. Sometimes it will miss some points, but it has the ability within the algorithm to fill in those points based on past and prior frames that has been digitized.
Also, you see here one view. Usually we take 2 or 3 views. So if there is any missing point in one view, it will fill it from the other view. But in this case, even one view will do very well.
And you'll also notice that not only are we doing the event, but it will stop and go backwards frame by frame in order to enhance the quality of the AI digitizing. Now we're going backwards. So the algorithm has an opportunity to correct itself from going forward or backwards. And we'll just let it proceed until we have a box on the bottom that says, do you want to do another video?
So all this process is done automatic,
Without markers.
without markers.
Indoor, outdoor, doesn't matter, so long as you have good light. And we'd have this choice now, do you want to do another video? And we'll say no. Next step is to bring this video, this digitized video, into our digitizer and create a project. In order to do that, we go up to File, and we say New Project, and we'll take the same name as our old project, but we'll make this number 2. 12. Number 2. Open. Now it wants to know, do I want to define the points? Do I want to define the control? And I have the choice of doing this manually, or I can read from one that I created earlier, which is Discus Demo number 1. And you can see now we have 18 points to digitize. We have 4 control points. We'll look at the control points in centimeters. And we have X and Y only, no Z. If we want to do 3D with 2 cameras, then we have to also include the Z. But for now, we'll just demonstrate with 2. And we'll say OK. And now it's asking to select the digitized video, which is here. OK. Now the program has to define whether it's an interlaced or progressive video and whether the fields are in the proper order. So we say, OK, do your job. This screen allows us to correct an offset of 1 to 2 frames in case the algorithm did not pick the proper frame. But we'll say, okay. It says, fine, I've done my job. Now you have to reopen it. To reopen it, we come up to the top where it says 1T, click Open View, and here's our view. And now it presents us with the video overlaid with the digitizing that we did automatically. And we'll go forward a couple of frames just to see that it is moving properly. But in order to create a live project, we have to have control points. So we'll select Control. In this box, we can either digitize from scratch, or we can select Read and read the points that have already been defined in another video. So we'll choose Read, and I'll go to demo number 1. And here we see we have a fixed point, and we have 4 defined points of our calibration. So we'll say Control, Finished, and we'll go forward a couple frames. We see it's working fine. Now all we have to do at this point, instead of going through hundreds of frames and digitizing them, they've already been digitized. Now we'll say, let's do the transformation and filtering. After filtering, it will open up to our display module, and we'll see how we did. We're now in display, and we see we have a stick figure of the disc destroyer. We'll play him. And again, this is only a 2D file. It looks pretty good.
This process before would take probably 2 hours to get to this point, and now it's 5 minutes.
We can also do this. We can say view multiple, and it'll give an overlay of all the frames that have been digitized. So we'll take that off for now. And next we'll take a look at the actual video that's been digitized. Demo 2. There it is. Put that side by side, and we can run this together. But we'll stop it for now, go back to the start, and as a coach or a scientist, now I want to define what kind of data I want to see from this performance. So we go to what's called 3D. We choose our file, open, and on this particular app, we choose 3D. Now we can choose what type of data do we want to see on a graph. We have the choice of something in linear, segment angle, joint angle, and in quantity we have raw position, displacement, velocity, acceleration, and here we have all the points that were digitized. We can choose any point that we want. We can have more than one. We can have as many graphs as we want overlaid. So in this case, Dr. Ariel, what would you like me to do? We'll take linear.
Yeah, let's take the velocity of the hand.
The hand.
The right hand that's
right hand.
through the discus.
And instead of choosing X and Y, we'll say 3D, which will give us accumulation summary of the X and the Y angles. Select. Would you like to see another
Well, let's
graph?
look on the feet, for
On the
example.
feet,
Take the
okay.
both feet.
Both feet. All right, so we'll go to right foot, velocity, 3D, select, and then we'll come down to the left foot, velocity, 3D, select. Okay, we'll finish. Now we want to make a graph, so we come up to the top under the heading of graph. We have many choices there, but in this case we'll just say graph the data that we've just selected. I look it over. We can put the data, the graphs on a single graph per box, or we can have all of them together. We'll choose to do all at once. And we'll say, okay. And there we have a graph of the right hand, the right foot, and the left foot. Now, it doesn't make any sense to look at this by itself, so we want to see it in conjunction with the stick figure and the video. So we'll go to options, windows, and tile. This gives us a little square tile for each of the events we've just selected. Amazingly now we can click on forward and we'll see everything in sync. The stick figure, the video, the graph. We can stop it anywhere along the way. Go back, forward, and then continue on, continue forward. Now I want to see some numbers. So I can do this. I can go up to this little table and we can say, give us a table with all the numbers on it. And here it is on the side. So again, we'll say window tile, include that.
We can make this window a little bit.
Yeah, we can go bigger on this.
Yeah. And expand this one. Yeah.
And now as we go forward, not only do we have the graph, but we have the actual numbers for the 3 items or 3 body parts that we've selected. If we stop anywhere along the way, it tells us that the right hand is moving at 246 centimeters per second, the right foot at 40, and the left foot at 57. We'll let that continue.
Or you can select particular point on the graph and label it.
We can do that by going to Tools and Label. Oh, we have to select this box first. Tools, Label, Add, and we'll do a value on the Y scale. So we'll say OK. And now I want to choose the frame where the release occurs. Actually, I'll first go forward a little bit. That's the one we want to choose. And now we'll go back to Tools and we'll do a label, add value on the Y again. And we'll select the same point that the computer tells us is the current frame. And it tells us that we have a speed or velocity of 1,308 centimeters per second at release. So as you can see, this is a wonderful innovation for the biomechanist or the scientist to pick and choose what kind of data we want to see from the performance. And our dream about this is to be able to have this workable and understandable by the everyday coach, the parent, the student, athlete, whoever wants to look at their own performance and make a judgment as to how to perhaps improve it. So closing, Dr. Ariel, would you have any other comments for us?
Well, the next step is that we're going to do it where parents can go with 2 cell phones, collect the data on their children throwing or jumping or whatever it is, and within a few minutes show particular critical value they are interested in.
So with that, we'll say goodbye and hope you've enjoyed our presentation. And for our past, current, and future clients, we'll hope you'll follow the development of this. And when it's ready, we'll definitely have it released to the public for acquisition and use.
One more statement to make, that Bob and I working together for 45 years, and we have a bunch of programmers. We're all getting a little bit old, but we have Jeremy, Rudolph, Justin, and many others. So we keep going. We never stop.
We have a great team.
Yes.
Thank you and goodbye.